In the previous video, we discussed the Bronsted-Lowry theory of acids and bases. In this video, we are going to be talking about the example problems given in your textbook. So the first of all, I just wanted to recap on this. In this reaction, hydrochloric acid plus water gives rise to H3O plus and Cl minus. So HCl over here is the Lowry Bronsted acid. H2O is the Lowry Bronsted base. The H3O plus is the conjugate acid of the base, and the Cl minus is the conjugate base of the acid. So essentially, HCl is losing a proton to give us the conjugate base, that is Cl minus. So HCl is giving us Cl minus, and H3O plus is formed from H2O. Now let's look at the difference. Okay, the acid and the difference between the the acid and the conjugate base. The conjugate base has one less proton compared to the acid. The conjugate acid, on the other hand, has one extra proton compared to the base. So H2O, H3O plus. So the conjugate acid has one extra proton, whereas the conjugate base has one less proton. Now let's look at the questions given below. 7.12. What will be the conjugate bases for the following Bronsted acids? So we've been given we have asked to write HF, H₂SO₄ and HCO₃ minus. So we just discussed the conjugate base of a Bronsted acid will have one less proton compared to the acid. So here, in case of HF, that is the first one here. So the HF should have lost the proton for it to get to the conjugate base. So, excuse me, the conjugate base for HF is going to be F minus. And when a proton gets out, it will leave behind the negative charge. H₂SO₄ loses a proton to give us HSO₄ minus. HCO₃ minus is going to be, H is going to get kicked out, so it will be CO₃, 2 minus. This is because when the H plus gets kicked out, it's not taking any electrons with it, right? So it's leaving the electrons behind, which means our final ion will have a negative charge. Since HCO₃ already has a negative charge, when the proton gets kicked out, it will have a -2 charge. The next question, write the conjugate acids for the following. So conjugate acid will have one extra proton compared to the Bronsted base. So the first one is NH2 minus. The second one is NH3. And the third one is HCOO minus. Now, when a proton comes in, right, when a extra proton gets added, this negative charge and that proton's charge will get neutralized, like it'll get cancelled out. So when this particular molecule has another proton, H plus, get added to it, it will form NH3. Okay, next one, in case of NH3, when a proton comes in, it's already neutral, so it becomes positive. So you have NH4 plus. The third one is similar to the first one. It already has a negative charge. Negative and positive will get cancelled. So HCO. OOH. Okay, so basically, that's it. We added a proton. For a conjugate acid, we are adding a proton. For a conjugate base, we are removing a proton. Excuse me, I'm so sorry. Okay, now we already discussed this. There are certain species which act as both conjugate as both Bronsted acids as well as bases based on what they react with. So such species are H2O, HCO₃ minus, HSO₄ minus, and NH₃. So the conjugate acid, it's basically the same table, but I'm going to explain it. base. So conjugate acid and a conjugate base. So for the conjugate acid, they should have one less. For the conjugate acid, they will have one less proton. In case of a conjugate the base, they will have, oh, I got it the other way around, didn't I? So for a conjugate acid, let's erase this really quick. Okay. So for a conjugate acid, it's going to have one extra H plus. In case of a conjugate base, one less H plus. So one less proton. So the conjugate acid, H₂O. H₂O, one extra proton, which will be H₃O plus, because neutral already. Since it's already neutral, the positive charge that the proton will bring with itself is going to get added to it, right? So it becomes, so it's going to become a positively charged ion. On the other hand, for when it loses a proton, then it'll form OH minus. So the proton is getting kicked out. Because of that, it will have a negative charge on the OH. Next is HCO₃, one extra proton, which will mean H₂CO₃. The negative charge and positive charge is going to get cancelled out. And when one less proton exists, then it'll be CO₃, 2 minus. HSO₄ minus is going to be one extra proton is H₂SO₄. One less proton will be SO₄, 2 minus. NH₃ is going to be NH₄ plus. One less proton is going to be NH₂ minus. So this is basically it. If you do think that you want like more details as to why it's a plus, why it's a minus, do let me know and I will put a video for that. With that, we're done with the example problem 7.12 to 7.14.